All right, diving in today, wave machines. But hold on.
Okay.
Not those giant pool things for surfers.
Right.
We're going smaller scale, like tabletop educational physics you can see kind of thing.
Yeah. Those deceptively simple. You got those horizontal bars all connected with a torsion rod.
I'm intrigued.
You'd be surprised, honestly, what they can show us about how waves, like, really act. Complex stuff.
I get it's visual, helps us grasp it. But this specific wave machine, the one John Shive designed,
Yeah.
what makes it so special? It got famous, right? From that Simple Waves film.
The Shive machine is brilliant. But in a simple way, like you adjust the bar lengths, you can actually simulate waves in different mediums. And seeing it, that's key way. Watching it travel down, speed up, slow down, even reflect.
Whoa.
All because you tweaked something. That's understanding way beyond just like equations on a page.
So mini hands-on physics lab.
Exactly. And speaking of hands-on, you can even build one yourself.
No.
Duct tape, skewers,
Okay.
and get this, jelly babies.
Jelly babies. Hold up. What do those have to do with wave physics?
They add mass, which is like fundamental to how waves behave. Fun way to explore that. Change the mass. See how the wave speed changes.
So they're not just like decoration on the side?
Nope. Part of the experiment. Show how mass affects the wave traveling. But we'll get into that. First, some basics this machine helps us understand.
Sounds good. So beyond just seeing the wave, what kind of knowledge do we get?
Starts with the basics. You got the vibrating source. That's you twisting the rod. Makes a disturbance, travels through the machine. Energy's getting transferred. But key thing here, it's the wave that travels, not the stuff itself. Bars move up and down, sure, but they don't, like, go anywhere along the machine.
Like that stadium wave, right?
Exactly. People stay put. But the wave, the energy, that rips through the crowd.
Okay, that's trippy.
And wave machine can show other stuff, like reflection. What happens when the wave hits a fixed end?
Makes sense.
Amplitude, too. Height of the wave. Bigger pulse, more energy you put in. Bigger amplitude.
I'm seeing how deep this gets, not just back and forth motion. What about speed, though? Like, if I twist the rod faster,
Good question.
does the wave itself go faster then?
Common thought, but kind of misconception. Faster twist. You're making a shorter pulse, not a faster wave. Wave speed. That's set by the machine itself. Like how tight the rod is, how far apart the skewers are.
So more about the setup, not my action. Interesting.
Precisely. And this leads to those key terms you mentioned. Amplitude, wavelength, frequency, wave speed.
Right.
They're all connected, and the machine lets us see that.
Okay, break that down a bit. Amplitude's height, we got that. But the others?
Wavelength.
Yeah.
Distance between like two peaks of the wave or two troughs.
Okay.
Frequency is how many waves go past a point each second. And wave speed, well, that's how fast it's moving.
Makes sense.
And they're all tied together. Simple formula, but powerful. Wave speed equals frequency times wavelength.
Starting to see how much this simple thing can teach us. Waves are complex. What else can we explore with this machine?
Yeah.
All right, we've covered some ground, basics, then wave speed, frequency, that wavelength thing.
Yep.
What else can this wave machine show us?
So far it's been, transverse waves, the bars going up and down, but the wave itself travels sideways.
Oh, right.
But there's another kind, longitudinal wave.
Oh, like sound.
Exactly. Where the air, it like compresses and spreads out along the direction the sound's going.
Yeah, I remember that.
And our machine, maybe not visually showing that, but conceptually, it helps.
Okay.
Think of the spaces between the bars. Longitudinal wave, you get these bunched up spots, compression, and then spread out ones, rarefaction. The bars kind of show us that.
So even if we can't see it, the machine's like an analogy.
It's all about making those connections. And speaking of another cool concept.
Interference.
Interference. Is that like when two waves crash and make a bigger splash? More to it than that. When waves interfere, their amplitudes, they can add up.
Okay.
Constructive interference. Or they cancel each other out. Destructive.
So like working together or against each other?
Exactly. And depending on the waves, you get these like patterns. Super interesting.
So two pulses down the machine at once.
They totally interfere. Could get bigger, could partly disappear. Depends on timing, size of the pulses.
Whoa.
Great way to see how interference works.
Complex stuff happening on this simple setup.
And interference is everywhere in the real world, like soap bubbles, those colors, or noise-canceling headphones.
Yeah.
It's all interference principles.
I never realized it's like way more to this wave machine than I thought.
Always more to discover. Ever heard of diffraction?
Diffraction. Vaguely. From physics class years ago. Isn't it like Waves bending around corners.
Good way to put it. Waves, they spread out going through an opening or around something blocking them.
Not just straight lines, then.
Nope. Like
That's-
ocean waves hitting a pier. They don't just SOP. They bend around it, keep going. Diffraction.
So on our machine, can we see that happening?
Maybe not as clear as interference, but
Oh.
imagine a barrier or a gap, like partway along, wave comes along,
Mm-hmm.
doesn't just bounce back. Some of it bends around the edges, keeps going.
Finds a way through.
Exactly. And how MUCH it bends depends on the obstacle size compared to the wave's wavelength.
So small wavelength, less bendy.
Basically,
Mm.
longer wavelength, more adaptable.
Okay, makes sense.
This diffraction thing, huge in like designing concert
If
halls.
it's a sound.
Make sure the waves reach everywhere. Same with speakers, even wireless stuff, your cell phone signal.
Whoa.
Needs to bend around buildings and stuff.
So we're swimming in waves we can't even see?
Pretty much.
Yeah.
And this machine helps us understand how they work.
Mind-blowing that something so, like, abstract affects our lives this much.
Right. And it's not just phones. Medical imaging,
Hmm.
earthquakes, materials.
Really?
Waves are fundamental, like
Mhm.
the key to understanding how the universe works.
Not just some random thing, then. It's like a language.
Exactly. And the
Right.
more we know that language, the more we can use it. Clean energy, medicine, who knows what's next.
This has been a lot. I feel like I've only, like, dipped my toe in.
Always more to find out.
Yeah.
But for now, let's let this sink in. Get ready for the final part of our wave machine adventure.
Wow, so many cool things. Basic wave stuff, then interference, even diffraction. It's amazing what this little machine can show us. What else is there, wave-wise?
Well, we're all about energy these days, right?
Yeah.
So, got to talk about wave energy itself.
Oh, you mean like getting power from ocean waves? I've heard about that. Those wave energy converter projects.
Exactly. They take the motion, the kinetic energy of those waves, turn it into electricity. Clean, renewable, huge potential.
Right.
Our machine won't power your house. BUT, it shows the basic idea.
How so? How would we see that energy conversion?
Say you put a little weight on one of the rods,
Okay.
wave goes by, that energy gets transferred to the weight, makes it move.
Yeah.
Mini version of how wave energy can DO stuff.
Like a teeny power plant. This simple model connects to such big tech. That's
Yeah.
wild.
Fundamental principles, always relevant.
Yeah.
And speaking of connections, think about like telecommunications.
Uh-huh.
Our world's wireless now, right? All depends on waves, how they travel.
So my phone, Wi-Fi, those are all waves, just invisible.
Exactly. And knowing how they act, the reflecting, diffracting, interfering we talked about,
Yeah.
that's how you get good signal, good coverage. We're basically in an ocean of waves we can't see.
And this machine gives us a peek into that. Crazy.
Right. And it's not just phones, medical imaging, like ultrasounds, those are waves, earthquakes, studying how the ground shakes, waves again. Even what stuff is made of, material science, uses wave principles.
Wow. So waves are like the key to so much of how things work.
Pretty much. And
Yeah.
the more we get that, the more we can use it to our advantage.
It's kind of mind-blowing. This whole deep dive, I feel like I just scratched the surface of waves.
Always more to learn. But hey, gonna end with a thought-provoking question, right?
It hit me.
We saw how each rod on the machine, it affects ones next to it. One little nudge, the whole system feels it. Where ELSE in the world do we see that? That interconnectedness thing happening through waves, maybe?
That's a good one. Makes me think about like ecosystems, how everything's linked up.
Right.
Or social networks. One post goes viral, boom, everyone's talking about it. Even like the universe itself, space and time all connected somehow.
Exactly. A simple wave machine, and it gets us thinking about big ideas. That's the beauty of it.
Well, folks, there you have it. Our wave machine deep dive. Hopefully your brain is making some waves of its own now. Until next time, keep exploring, stay curious. There's always more to discover out there.